Hello everyone, welcome to another design programming lecture. Today we're going to be exploring behavior. Let's just dive right in and we can do that first by asking, what is behavior? What is a behavior? I've done the obvious thing, and that is to look at the Wikipedia page for it. And here we have a definition which we're going to, in the next few minutes, unpack and explore. So, the actions and mannerisms made by individuals or organisms, systems or artificial entities in conjunction with themselves or with their environment. Very curious. That's a lot of things. The things that stand out to me about this definition are that we have two key operative terms here, actions and mannerisms. Both of those are going to need to be understood a little bit further. But this applies to not only just people, but to organisms and systems, as well as artificial entities. In this class, we think a lot about artificial entities, programmatic structures, artificial behaviors, those kinds of things that are embedded in generative designs. We also think a lot in design about systems. So it seems to me that perhaps behavior is actually at the core of the kinds of ideas that we have in both this class, but as designers as well. So, that first thing, what is an action? This is kind of one of those terms that cuts right down into the kind of the very curious nature of a generalizable pattern or structure. An action immediately draws me towards the kind of philosophical definitions. Wittgenstein is a famous philosopher who thought a lot about technology and people's behaviors. He could be thought to have said, this is not a quote of his, but it summarizes his ideas well, that driving a car is an action since the agent intends to do so, but sneezing is a behavior since it happens independent of the agent's intention. Now, that could take a minute to wrap your head around, I think, so feel free to pause and have a think on that, but an action being an intention, related to an intention, and there being a distinction between an action and a behavior that is about the agent's intention itself, immediately brings up, what do we mean by an agent's intention? So I think that given a philosophical approach to the idea of behavior, we have this kind of working theorem. Actions and behaviors are related, but intentions is what makes them different. And I can think of some ways I think that might be true, and other ways it might not be. And I'm not too sure. So it's worth checking out other ways of thinking about this problem as well. My next immediate leaning is to start looking at the way that cognitive scientists think about behavior. One of those cognitive scientists, Kahneman, is very famous, won a Nobel Prize for his work in Thinking Fast and Slow. And it's definitely a book worth checking out, an incredible exploration of the way that humans think, and particularly for designers, experienced designers. It's a necessary kind of understanding about the way that the world works. People have all kinds of fascinating and generalizable features about the way that we think. So Kahneman's approach here is to talk about two types of thinking, and this is what Thinking Fast and Slow, the book, is about. But the two kinds and modes of thinking, that is, there is the deliberative and the reactive, these two ways of thinking. One is fast and one is slow. So, no surprises, the one that is deliberate is conscious, or system 2 thinking is often described as. It's slow and it's focused and it's self-aware. It's what you think about as thinking when you're sitting down and you're in your own head. You're thinking a thought and you can say, I'm thinking. You self-identify as acting in your mind, thinking in your mind. And the limitation of System 2 is that it's woefully limited in how much information it can handle at a given moment. So it's difficult to even hold 7 unrelated numbers in your short-term memory. It's difficult to remember everything that you need to do on your to-do list without writing it down. This is the kinds of limitations of System 2 thinking. It's very good at particular things, going over an idea, thinking through, imagining, thinking through a future scenario. This is the kind of thing a System 2 thinking is really good at. But it is very bad at acting quickly. It requires space and time. And in fact, a lot of the time, you can get pulled out of System 2 thinking or never enter into System 2 thinking when you have no reflection or reflective moments in your day. So this means we rely on reactive thinking for much of our work, much of our real work of thinking. So reactive thinking, that is System 1 thinking, the very fast kind of thinking, is reaction-based. It is about reacting to any given situation. There's lots of different examples of this, but you can think of reactive thinking as any kind of thinking that is just automatic, where you haven't got to intentionally think through what you're about to do. In fact, you just do it. Obviously, speaking is one of these things. Constructing a thought and saying it is reactive. It just happens in the moment. You reach a state where you are proficient enough in whatever that thinking is that you just do it. This can also be like talking about driving as well, like that previous example. This could also be have reactive components to it. And in fact, learning to drive is a good example of this. So you move from that intentional kind of thinking where you have to be very deliberate in your approach to learning how to drive. You think about where your feet are, you think about where your hands are. But eventually, as you begin to build that skill and get better at it, you develop reactive thinking. And so that leads us to the conclusion that reactive thinking is trainable. And an example of this is simply this. The example of trying to hold 7 unrelated numbers in your head at one moment is quite difficult, but you can remember your phone number. So it's not that you can't actually remember 7 digits in your mind, that's a cognitively impossible task for you. No, it must be something else. It's simply that you have to develop a certain level of proficiency. You have to repeat that task enough. You have to habituate it. For example, sometimes we call a trained action a habit. So habits are really very closely related to behaviors, and in fact, habits describe behaviors. But we all know how hard habits are to develop, and sometimes they're hard to stick with. So we actually have a way of describing that, and cognitive scientists and behavioral designers will talk about this. Talk about the intention-action gap, which is where we fail to act on our intentions. We intend to do something, we want to habituate it, we want it to become a habit, or maybe it was a habit, and we're having trouble making it a continuous habit. But it describes when we fail to act on our intentions. This can, going to the gym, eating food the way that you want to eat food, or studying. These are all ways, good examples of things that we try to habituate, try to get better at doing very habitually. But we often fail to do so. So that's a lot of different things. We've got actions, we've got types of thinking, we've got how they relate to behavior. These are all swirling around these ideas. We haven't really arrived at any conclusions. So let's rephrase this. Perhaps the definition that is most useful for us here is that actions are the outcomes of thinking. Actions are what we do after thinking, whether that be in a very deliberate fashion or in an automatic fashion. This thinking then produces behaviors themselves. The thinking and the actions combined together, no matter what type of thinking they are, no matter what type of actions they are, habitual or otherwise, they produce behaviors. And it's from that point and this kind of working definition, which I don't think is perfect, but is useful for us in this context, that I think allows us to continue forward to start talking about, you guessed it, cybernetics. I've got an example from cybernetics which will continue to elaborate on this understanding of behavior and this definition that we've just talked about. So last week we saw Edward Innowitz's audio reactive piece. This was this creepy looking skeleton thing that has 4 microphones. Those 4 microphones are listening at any point in time. and they turn the actual entire sculpture towards the loudest point in the room. If you remember in the video from last week, and if you haven't watched that, go back and watch it. I think it's a great video. Not the one that I recorded, the video of the exhibition. But it is about the object itself. It moves towards a louder sound. It's a very curious, interactive system. And as it is a cybernetic system, we have to begin to frame that system in the way that the cyberneticists would themselves. And that is to think about the input, the process, and the output of the system. Now, input, process, output models, now if you go and look that up online, is very much a systems theory kind of approach to thinking through the structure of computational problems. But the core, the seed of this idea was with the cyberneticists in the 50s. So an input is a sensor in this case. The microphones are the input. Process is the computational system, the thinking component, the computational system that actually produces the output, and that is the behavior, the way that the system moves itself. And so let's map that to what we've just talked about. Input, process, and output, we can think about them as related to, but not exactly mapping onto, action, thinking, and behavior. I think these two things relate very closely. They don't fully overlap, but they have a similarity to them. So actions, thinking, and behavior are three observable phenomena that we're looking for in our emergent designs. When we're thinking about the behavioral design of systems in the context of this course, we're thinking about the ways in which our system acts, the ways in which it thinks, and therefore the ways that it behaves. Remembering that our definition of behavior includes artificial agents. It includes computational agents. So even at the most simple, when we're talking about describing simulations or very simple behaviors that are embedded in objects that move on the screen, we can still apply this framework to them, and we can actually begin to endow them with this kind of vision of a more complex state, a behavioral state. And next week you'll hear more about that when we start to look at the nature of code and embedding simulations or analogies from the real world into our actual programs. So the final thing I want to talk about is Gordon Pasque. Gordon Pasque is another cyberneticist. And he was actually at MIT before the MIT Media Lab, a very famous design school with lots of amazing work for decades and decades. He was fascinated with cybernetic systems and was building them. And the images of Gordon Pasque's work from the paper that's referenced here, the architectural relevance of Gordon Pasque, are very much worth exploring. Some fascinating systems. He had some really unique ideas about the way that interactive systems behave and how we could endow those systems with behavioral visions. So the first one is conversation theory. So here's a quote from the paper. Now at the beginning of the so this is just to summarize, this is Usman Haque speaking about Gordon Pasque. Now at the beginning of the 21st century, Pasque's conversation theory seems particularly important because it suggests how, in the growing field of ubiquitous computing, humans, devices, and their shared environments might coexist in mutually constructive relationship. I think this is really fascinating. A mutually constructive relationship. I'm not sure if that summarizes my relationship with, say, my phone, right? There's definitely some benefits, but there's definitely some behavioral downsides to addictive technologies or technologies that are highly formative or easily habituated. But it's certainly the case that ubiquitous computing is a fixture of modern life. So thinking through what it actually means in terms of the behavioral design of these kinds of computing devices that are situated near us is obviously very important. And as designers, it's something that we must consider. But what Gordon Pasque is trying to get at here is that each of those objects, those designed objects, ubiquitous computing-enabled devices, aren't static devices, aren't devices that are uninterested in us themselves. Gordon Pasque instead theorizes that we're in a constant conversation with those devices. And that in fact, not only do we speak to our devices as they're around us, but they speak back to us as well. And it's through a conversation that we actually arrive at a relationship with those devices, the computational devices. And with that framing, the idea that you are in a relationship with a device, a technology, it actually brings with it a lot of associated thinking. It brings with it a new way of seeing the devices in your life and that are around you. I think it means a few things. It means you can certainly learn from devices, and that much is very obvious. But it also means that they can change the way you think about the world. And obviously, as a cyberneticist, Gordon Pasque was thinking along those lines, that these kinds of computing devices, the ones that would be in conversation with you, have the power to kind of change the world. Remembering this is obviously pre-internet as well. I think the point here is to say that when you're looking at an emergent or generative system in the context of this course, think about the conversation that the user will be having with it. What is the thing that they will discover or learn or find in your system? And how can you frame that as a set of design decisions which are considered to be mutually constructive or conversational in their nature? It's an open-ended question. Something to consider as you approach designing your systems. The second point to make about Gordon Pasque is underspecified goals. Underspecified goals, I think, are something that in a modern design context we really need to be thinking more about. It's so often that the specification of design requirements is extremely stringent, and Pasque theorized about this very coherently. Here's a quote from that same paper. If a designer specifies all parts of a design, and hence all behaviors that the constituent parts can conceivably have at the beginning, then the eventual identity and functioning of that design will be limited by what the designer can predict. It is therefore closed to novelty and can only respond to the preconceptions that were explicitly or implicitly built into it. I think this is a really fascinating paradigm for us to consider in a class where we're thinking about generative design. If a designer specifies all parts of a design, and then all behaviors will be known. Given the complex nature of modern technologies, the embedded IoT, machine learning, algorithmic nature of modern systems, this is obviously a huge and more complex thing than it was then, but it still remains true that if you start from the position when designing a digital object of having to define all components, then you are closing out novelty. And in fact, you are enforcing a functional view of the world in that design. You are limiting what can happen in that design. Now, we can obviously think of the utility of this, right? It's necessary to sometimes constrain the identity and functioning of a digital object. But in this course, we're very much interested in the opposite. We want to create opportunities for spontaneity, serendipity, and novelty. We want to create generative systems that emerge, have emergent properties built into them. And so, considering underspecification, that is, not knowing exactly how everything is going to work in your system, and I'm not talking about understanding the code, I'm not talking about understanding the behavioral aspects of what will happen when the parts of your code interact visually, is, I think, something very interesting to consider. In what ways can you create novel interactions in your systems, ones that allow for the functioning of the design to be explorative or not completely known in some way? This is the second thing to consider this week, is to think about exactly what that means for a design in this course, and something to have a dialogue about with both your peers and your tutors. All right, that's about it for this week.